Hi friends, this is Naresh. In this class I am going to explain about engineering mechanics, and today's topic is area moment of inertia of simple composite sections. Here in this class I will explain how to determine the area moment of inertia of these two sections. These sections having solid planes as well as hollow planes. So in this class, this one I consider as problem 1, and then after I am adding a small rectangle at right side, and this diagram I will consider as problem 2. Okay, before going to the problems, first of all you have to know the fundamentals about centroid and area moment of inertias. So the centroid of an rectangle lies at where its diagonals meet to each other. Therefore the intersecting point of these two diagonals is centroid. So CZ is the centroid of a rectangle. It lies at a distance of base by 2 from this side and height by 2 from this side. Okay, the given rectangle is symmetric about horizontal and vertical axis. Therefore the centroid lies half of the base and half of the height. Okay, here x axis I considered as a reference axis, as well as y axis also reference axis. Okay, whereas CZ is the centroid, therefore gx and gy axis are called centroidal axis. These centroidal axis passing through the centroid. Okay, therefore gx and gy axis are called centroidal axis. Here xx and y axis are called reference axis. Here x axis, xx axis and gx axis are parallel to each other. Similarly y axis and gy axis parallel to each other. Okay, so therefore for solving the area moment of inertia problems, we consider the parallax theorem. Okay, here area of a rectangle, that is capital A equal to base into height, that is here capital B is the base and capital D is the depth or height of a rectangle. Therefore the area of a rectangle equal to base into depth, that is A equal to B into D. Okay, now the centroid lies from at a distance of from here to here, the distance is base by 2, that is x bar, and from here to here the distance is y bar. Okay, y bar equal to d by 2 and x bar equal to base by 2. So igx, igy are the area moment of inertia about centroidal axis. That means about these axes. So area moment of inertia igx about gx axis equal to bd cube by 12. Okay, about centroidal y axis igy equal to db cube by 12, where b refers base and d refers depth. Okay, please remember this. And coming to the another section, that is circle having diameter, outer diameter capital D, or radius capital R, where radius equal to diameter by 2. Therefore the area of a circle, this is a solid circle, so the area of a solid circle equal to area A equal to pi r square or pi by 4 d square. Okay, in terms of radius the area of a circle equal to pi r square, as well as in terms of diameter the area equal to pi by 4 d square. Okay, here the given circle is symmetric about this horizontal and vertical axis. Therefore the area moment of inertia about these centroidal axis, both axes are same, that is Izx equal to Izy, because the given section is symmetric about these two axes. Okay, therefore Izx equal to Izy equal to pi d power 4 by 64. Okay, area moment of inertia of an circle equal to pi d power 4. Please see carefully. This is a pi d, diameter power 4 by 64. Pi d power 4 by 64 is the area moment of inertia of an solid circle. Okay, now coming to the another section, that is equilateral triangle or isosceles triangle. Okay, this is a right angle triangle. The formulas are same, but the location of centroid is different. Here the given this triangle is symmetric about this vertical axis. Therefore the centroid lies on this line. Okay, lies on vertical line. Therefore the centroid lies the centroid of a triangle lies at where its median lines meet to each other. Okay, therefore C is the centroid of a triangle at a distance of base by 2 and height h by 3 and 2h by 3. Please carefully. Here you have to consider the location of centroid from base always 1 h by 3, that is 1 by third part of height. From apex you have to consider 2 by third part of height. Okay, always you have to consider from apex point 2 by third height, from base 1 by third height. Okay, and this triangle is symmetric about this vertical line. Therefore the base by 2 the centroid lies at a distance of base by 2 and base by 2. Okay, but in case of right angle triangles, the centroid lies at a distance of base by 3 h by 3 from right angled corner. Okay, this is the right angle corner. So from right angle corner you have to consider 1 by third base, 1 by third height. Okay, from apex or sharp corners you have to consider 2 by third of height, from this side 2 by third of base. Okay, so the important note is the centroid of a right angle triangle lies at a distance of 1 by third of base and 1 by third of height from right angle corner. This is very important. Okay, so in our problems we are using these formulas, so you have to observe carefully. Look at the problem. The question is, determine the area moment of inertia of an given composite section. Okay, this is the question. Determine the area moment of inertia of an given composite figure. So the figure is consists of one solid square section and one hollow circle. Okay, this portion is hollow, this portion is solid. Therefore the given figure consists of one solid and another hollow portions. So for solid portions you have to consider as positive area, for hollow portions you have to consider as negative area. So you have to mention negative sign for these areas. Okay, solid sections you have to consider as a positive sign, for hollow portions you have to consider negative sign. This is very important. Okay, now the given figure, you have to, first of all the given figure is split up into two parts, that is one part is this square section and another part is hollow section. So you have to number as 1 2. Okay, I consider this one as a section 1 and this one as a section 2. Now I consider the reference axis, that is x axis at the bottom edge and y axis at the left side edge. Okay, first of all I consider section 1 as a solid square section, square or rectangle section having dimensions base b equal to 60 mm and depth d equal to 60 mm. Therefore where b refers base and d refers depth or height. Okay, therefore the area of a square section equal to a1 equal to base into depth. So this is the area of a rectangle or square. So area equal to base into depth, that is 60 by 60 is the area of a square. Now I consider the hollow circle as section 2 having dimensions pi 20 mm. Pi means diameter 20 mm. Okay, and radius equal to half of the diameter. Therefore the radius of a circle equal to r equal to 10 mm. Okay, the area of a circle equal to pi r square or pi by 4 d square. So area 2 equal to 314.15 mm square. And the center of a circle lies at a distance of 40 mm from y axis and 20 mm from top right side corner. So these dimensions are given in question. Now I am drawing the diagonal lines to determine the individual centroids. So these are the diagonal lines to locate the centroid of a square section. Therefore C1 is the centroid of a square section. It lies at a distance of x1. That means from centroid C1 to y axis, the distance between y axis and centroid C1 is x1. X1 equal to half of the base, that is b1 by 2, that is 60 by 2 equal to 30 mm. Already we have discussed in previous slides. So the centroid of a rectangle lies at a distance of half of the base and half of the height. Okay, similarly at a distance of y1 from x-axis. Okay, the distance between x-axis and centroid. Okay, the vertical distance between centroid and the horizontal x-axis is called y1. y1 equal to half of the height. Okay, for rectangle and square sections, the centroid lies at a distance of half of the base and half of the height. Okay, so therefore height equal to 60 mm, therefore half of the height equal to 60 by 2 equal to 30 mm. So x1 y1 are the coordinates of the centroid C1. Now the center point of a circle, this point as a centroid of a circle. So C2 is the centroid of a circle at a distance of x2 equal to 40 mm. Already it is given in our question. So from here to here, the horizontal distance between y axis and the centroid C2 is 40 mm, that is x2. Okay, and the vertical height between C2 and x axis is called y2. So y2 equal to the total height of a square equal to 60 mm, but you have to subtract this 20 mm distance. So from here to here the distance is 40. Therefore y2 equal to 40 mm. So x2 y2 are the coordinates of centroid C2. From figure, x1 equal to base by 2, y1 equal to depth or height by 2. Now x2 equal to 40 mm, y2 equal to 40 mm. Okay. Now in next slide I have written these values in a tabular form. Okay. From figure, I consider section 1 as a rectangle or square, section 2 as hollow circle. Now these are the dimensions, and these are the individual areas, and x and y are the coordinates of centroids. And from previous slides already we have discussed about area moment of inertia. Therefore igx, igy are the area moment of inertia about centroidal axis. Okay, igx is the centroidal x-axis, area moment of inertia about centroidal x-axis, and igy is the area moment of inertia about centroidal y-axis. Okay, already we have know about the area moment of inertia for rectangle equal to bd cube by 12 and db cube by 12. For circle, igx equal to igy equal to pi d power 4 by 64. Okay, these are the values. Okay, from general expression, the centroid xc is the distance of centroid or center of gravity from y axis, and yc is the distance of centroid or center of gravity from x axis. From general expression, x equal to a1 x1 minus a2 x2 by a1 minus a2, and the answer is x equal to 29.04 mm. Similarly, yc equal to a1 y1 minus a2 y2 by a1 minus a2 equal to yc equal to 29.04 mm. In this case, I have considered negative sign, because the given figure consists of solid rectangle. That means I have considered positive sign for solid sections and a negative sign for hollow sections, where section 2 is a hollow circle. Okay, so you have to subtract area 2 from area 1. Okay, that's why I am consider negative sign. Okay, now this is CZ, the centroid, the position of a centroid. Okay, CZ is the final position of a centroid of an entire section. Okay, C1, C2 are the individual centroids, whereas CZ is the centroid of an entire composite section. CZ lies at a distance of xc from y-axis. That means the horizontal distance between y-axis and CZ is called xc. xc equal to 29.04, and the vertical distance between CZ and x-axis is yc. Okay, yc also 29.04. Okay, this is the final position of a centroid. To determine the area moment of inertia about centroidal axis, here igx, igy are the area moment of inertia about centroidal x-axis and y-axis, but ixx, iyy are the area moment of inertia about reference axis. Okay, here ixx and iyy are the area moment of inertia about reference axis. This is x-axis, xx axis, this is y axis, this is gx axis, this is gy axis. Okay, gx and gy axis are called centroidal axis, xx and y axis are called reference axis. Therefore already in previous slides already we have explained about parallax theorem. Gx and xx axis are parallel to each other. Similarly, gy axis and y axis are parallel to each other. Therefore I consider the parallax theorem. Okay, area moment of inertia about x axis is equal to Igx1 plus area 1 into yc minus y1 whole square for section 1, that is a solid section rectangle. Now you have to subtract the value of area 2 because area 2 is a hollow circle. Therefore I consider negative sign for section 2. So therefore minus Igx2 minus a2 yc minus y2 whole square. Here yc, xc are the coordinates of centroid. Okay, y1, y2, x1, x2 are the coordinates of individual centroids. Okay, and the answer is Ixx equal to 1037727.578 mm power 4. Here the units for inertia, area moment of inertia is mm power 4, whereas centroid having units only mm. Similarly, area moment of inertia about y axis, that means these axis. So Iyy equal to Igy plus area into xc minus x1 whole square minus Igy2 minus a2 into xc minus x2 whole square, and the final answer is Iyy equal to 1037727.578 mm power 4. Okay, these are the final values for this composite section. Now coming to the another problem, it is also similar to previous problem, but I added as a right angle triangle. Okay, now this figure consists of 3 sections, that is one is square section, and another one is hollow circle, and third one is solid triangle. Okay, so the question is determine the area moment of inertia of an given composite figure. Okay, first of all, the given section is split up into 3 sections, that is section 1 as a square, section 2 as a hollow circle, section 3 as a right angle triangle, where section 1 and section 3 are solid sections. That means you have to consider positive sign for area 1 and area 3, but area 2 is the hollow section. Therefore you have to consider negative sign for area 2. Okay, now I consider x-axis at the bottom edge and y-axis at the left side edge, and this is origin. The answer is same for rectangle and square sections. Okay, area of a square equal 60 by 60, that is 3600, and the area diameter pi equal 20 mm and radius equal 10 mm. Therefore area 2 equal to pi r square equal to pi into 10 square. 10 square equal to 314.15 mm square. Now I consider the third section as a right angle triangle. Right angle triangle having dimensions base b equal to 30 mm and height of a triangle equal to, from here to here, the height of a triangle equal to height of a rectangle, that is 60 mm. So base 30 mm and height 60 mm. Therefore area 3, the area of a triangle A3 equal to half into base into height. Okay, the area of a triangle equal to half into base into height, that is equal to 30, base equal to 30 and height equal to 60. So 30 into 60 by 2 equal to 900 mm square. So area 1, area 2, area 3 are the individual areas, whereas A1 minus A2 plus A3 is the total area of a composite section. Okay, now I am drawing the diagonal lines to locate the centroid of a rectangle. So the intersecting point of these two diagonals is C1, that is centroid of a rectangle at a distance of x1 from y-axis, that is half of the base. So the base of a rectangle equals 60 mm, that is half of the base equal to x1 equal 30 mm, and y1 at a distance of y1 from x-axis, that is also half of the height. That means half of the height equal to 60 by 2 equal to 30 mm. Now C2 is the centroid of a circle. The centroid of a circle lies at center of the circle. So this is the center point of a circle, therefore center point is equal to centroid of a circle. So it is that the centroid C2 lies at a distance of x2 from here to here. From here to here the distance is x2 equal to 40 mm. It is already given in problem. Okay, therefore from here to here x2 equal to 40 and y2 equal to from here to here, the vertical distance between C2 and x-axis is also equal to 40 mm, because the total height equal to 60 mm and from here to here the distance is 20. Therefore you have to subtract a value of 20 mm from 60. Therefore y2 equal to 40 mm. Okay, from figure x1 equal to 30, y1 equal to 30 and x2 equal to 40 and y2 equal to 40. Okay, now in next slide I have written these values in tabular form. Oh sorry, here third section is there. So C3 is the centroid of a triangle. The centroid lies at a distance of x3. So the distance between y-axis and centroid C3 called x3. x3 equal to base of a rectangle plus 1/3 base of the triangle. Okay, already we have discussed in a previous slide. So the centroid of a triangle lies at a distance of 1/3 part of base and 1/3 part of height from right angle corner. Okay, from right angle corner you have to consider 1/3 of base and 1/3 of height. Okay, so from here to here the distance is 1/3 into base 30, that means 10 mm. From here to here 10 mm and from here to here the base is 60 mm. So 60 plus base by 3 is the x3 value. Similarly y3, from here to here the distance between centroid C3 and x-axis is y3 equal to 1/3 height of 1/3 height of a triangle. That means the total height of a triangle equal to 60 mm. Okay, (60 by 3 equal to 20 mm. So y3 equal to 20 mm. So these are the section numbers, plane types and dimensions, areas, individual areas. Area of a rectangle equal to base into height, area of a circle equal to pi r square, area of a triangle equal to half into base into height. Okay, these are the coordinates of centroid, individual centroids, and IGX, IGY are the area moment of inertia about centroidal axis. GX and GY are called centroidal axis, and I refers area moment of inertia about centroidal x-axis. This is the area moment of inertia about centroidal y-axis. Okay, already we have discussed about area moment of inertia. Area moment of inertia for rectangle equal to BD cube by 12 and DB cube by 12. Okay, for a circle IGX equal to IGY equal to pi d power 4 by 64, as well as for triangle IGX equal to BH cube by 36, where B is the base, H is height of a triangle. So BH cube by 36 for IGX, HB cube by 36 for IGY. Now from basic formulas xc is the distance of centroid or center of gravity from y-axis. So this is the centroid. From here to here, the distance between y-axis and centroid is called xc, and yc is the distance of centroid from x-axis. That means that vertical distance between centroid and x-axis is called yc. So this is yc, this is xc. The horizontal distance between y-axis and centroid is called xc, and the vertical distance between centroid and x-axis is called yc. Okay. Now from basic formulas, x equal to a1 x1 minus a2 x2 plus a3 x3 by a1 minus a2 plus a3. Here you have to remember, you have to consider positive sign for solid sections. Okay, here the solid sections are rectangle and triangle. Therefore I consider positive sign for rectangle, that is area 1, and positive sign for area 3. But I consider negative sign for area 2. Here area 2 is a hollow circle. Therefore you have to subtract the value of area 2 from other sections. Okay. Therefore I consider negative sign for area 2. So minus refers removing portion, removal part. Therefore x equal 37.84. This is x equal 37.84 from y-axis, and similarly yc equal to a1 y1 minus a2 y2 plus a3 y3 by a1 minus a2 plus a3. Here also same negative sign for hollow portions, and the final answer yc equal to 27.09 mm. That means from here to here the distance is yc. Okay. These two formulas are used for to locate the centroid of a composite section. But in this problem you have to determine the value of area moment of inertia. Okay. Therefore from parallax theorem, that means gx and xx axis are parallel to each other, and gy axis and yy axis are parallel to each other. Therefore you have to consider parallax theorem. Therefore the area moment of inertia about base, that is ixx. Okay, area moment of inertia about base equal to ixx equal to igx plus area 1 into yc minus y1 whole square minus igx2 minus area 2 into yc minus y2 whole square plus igx3 plus area 3 into yc minus y3 whole square. Here negative sign igx2 minus area 2. These two values for hollow circle. Okay. In inertia also we have to consider negative sign for hollow sections. Okay. And the answer is xx equal to 1275513.6836 mm power 4. Okay. Similarly, area moment of inertia about yy axis equal to iyy equal to 2267795.522 mm power 4. Okay, ixx iyy are the area moment of inertia about reference axis. Okay, igx igy are the area moment of inertia about centroidal axis. Okay, these two are the final answers for this composite section. Okay. Okay, thank you one and all.